All right, this is Unit 4, actually Section 2. So we talked parallelograms in the last video, really briefly, some properties. Here we're getting into more specific types of parallelograms, starting with a rhombus. So here's what it looks like, and that is just a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles, and a square is a parallelogram with 4 congruent sides and 4 congruent 4 right angles, sorry. Just erase that. So, this whole section's on rhombuses, rectangles, and squares. So here's a visual of our quadrilaterals so far. So parallelogram is just kind of the overarching term for these 4-sided figures. As long as the opposite sides are parallel. That's the whole key here. That's the definition of a parallelogram. So inside we have the rhombus, which is where we have 4 congruent sides. We have rectangles, which is 4 right angles, and then we have squares in the middle, which is made up of both 4 congruent sides and 4 right angles. So this little section here, kind of the whole idea here is just being able to identify different properties of 4-sided figures, specifically right now, parallelograms, including rhombuses, squares, and rectangles. So these always, sometimes, or never questions are kind of important, and we'll eventually fill out a chart to kind of compare. But let's start with this. A square is always it's always a rhombus. It's always a rectangle. It's always a parallelogram. And last but not least, it's always a quadrilateral, which is this whole unit. Quadrilateral is just a 4-sided figure. So anything that has 4 sides is always going to be a quadrilateral. A rhombus is sometimes a square, and it's also sometimes a rectangle. All you need is 4 congruent sides there, and some of those times those angles happen to be 90 degrees, which makes it square and or rectangle. A rectangle is sometimes a square if all the sides are congruent, and sometimes it is a rhombus. So some theorems, or you can just think of them as additional properties, of course, because we're not going to actually go through and prove them. But just really their properties. So in a rhombus, the diagonals do 2 things. First of all, they bisect the opposite angles. So that means, like, if I'm looking right here specifically at angle B, it bisects it, so that would be, those 2 angles would be congruent. These 2 angles down here would be congruent. It bisects the opposite angles, and they are perpendicular. Perpendicular to each other. So that means when they meet, they form a right angle. So in a rectangle, and therefore also a square, because a square is always a rectangle, the diagonals are congruent. We can't say anything else. We can't say that the angles are bisected, the opposite angles are bisected. We can't say that they're perpendicular, but we can say that they are congruent. A square is always a rhombus, like we said here, so these properties up here also apply to a square as well, just like this property applies to a square. So classify the parallelograms below Be as specific as you can. So, of course, you could just say, hey, number 1's a parallelogram. Number 2 is a parallelogram. But be more specific. So, number 1, we have diagonals bisecting each other because these segments are congruent. And we have that they are perpendicular, so this is what we would call a rhombus. Number 2, we have a right angle. We have two sides congruent, but we don't know that these sides are congruent. We don't know that this is a right angle, that's a right angle, that's a right angle. It looks like a square, I get it, but we don't have enough information, so we don't even know if it's a parallelogram, actually. We can only call this a quadrilateral. The only thing I know for a fact is that it has 4 sides. That's it. Number 3, again, it looks like a rectangle, but I don't know that these sides are congruent. I don't know that these sides are congruent. I don't know that these are all right angles. I don't. So, again, I don't even know if it's a parallelogram. Again, I can only call this a quadrilateral. Number 4. Well, guess what? More of the same. It's quadrilateral. It just has 4 sides. That's it. That's all I know. Number 5, though, it looks like a rectangle, and it is a rectangle because of this property right here. The diagonals are congruent. So these are, this diagonal is the same as that diagonal because each of this, I mean, you can go about this a couple different ways, but these segments are congruent. These segments are also congruent to the same segment, so therefore they bisect each other, therefore it is a rectangle. Number 6. So what we have is the diagonals bisecting each other, which would classify it as a rectangle. Or the diagonals are congruent, they are congruent, which would classify it as a rectangle, but they're also perpendicular. So it's not a rhombus because this second property here is not true for a rhombus. It's not a rectangle because this property is not true for a rectangle, but there is a shape that fits into both categories. It's always both, and that is a square. All right, so some calculations here really quickly to finish out the video. So we have all of the sides are congruent, which if you go back up here, we have a rhombus as a parallelogram with 4 congruent sides. Looks like that's what we have here. So we need to find x, we need to find y using the property. So first of all, y is going to be pretty easy because I know that these 2 sides are congruent. I can set them equal to each other. So we'll go ahead and subtract 3y, add 5, 3y equals 12, so y equals 4. So there you go. There's y. Now, we have, I gotta make sure I find it. Oh, last video, 4.1. Oh, I erased it. Parallelogram properties. So the angles that are adjacent to each other in a parallelogram are always supplementary. So therefore, if I take 2x minus 1 and I add 127, if they're supplementary, that means they equal 180. So we'll go ahead and solve quickly here. 2x minus 1 equals, I guess I could have done it the other way too. I'll fix it quickly. Let's combine these like terms here. 2x plus 126 equals 180. Then we'll subtract 126. It doesn't really matter, I guess, which way you go about it. But 2x equals 54. Whoa. Divide by 2, so x will equal 27. And there you go. So now it's telling you over here on the right that PQRS is a rhombus. Find the measure of angle QPR, the measure of angle QTP, and QS. So first of all, start with the easy one. If QT is 6, QS, well, TS is also 6 then, so that means QS is 12. QTP also should be pretty easy. Angle QTP. If you look at the properties of a rhombus, they bisect and they are perpendicular, which means when the diagonals meet, like they are here, they form a right angle. So that would make that 90. And then it says measure of angle QPR. So that's this angle down here. Excuse me. So that is going to end up being 60 degrees. And that takes care